Hey guys, welcome back to another Serpwizz video, and today we're continuing to go through the reports. Head over to www.serpwizz.com to get your free actual audit instantly. And today we're talking about ultimately reducing initial server response time. So as you can see, our root document took 2,340 milliseconds, which I think is basically 2.3 seconds. And your server response time, it needs to be as short as possible for your main document, i.e. your website effectively, to load, because all other requests depending upon you pinging your server and your server responding. If your server doesn't respond, nothing else is going to matter, my friend. So let's head over into the, let's just click this to learn more, and we'll walk you through, what this speaks of in terms of reducing server response time. So TTFB, which time to first byte is what it stands for. I was about to say I don't know exactly what it stands for, but now I do. So you'll have a look. Look. Fundamentally, the way that this works is an audit fails when the browser takes more than 6 seconds or 600 milliseconds for the server to respond to the main document request. Naturally, people don't like it when a page takes ages to load, and slow server response times are one possible cause for long page loads. So basically, if you've got a crappy server, that would be whoever your host is. So for example, I think we use DigitalOcean for Serpwizz. For Pearl Lemon, we use WPX. So talk to your host who hosts your server and see if you can either upgrade to a higher package or you can optimize your current server. So it's a combination of those two. And as you can see, when you basically navigate to a URL, i.e. you're whacking serpwizz.com, basically there's a network request to fetch the content. So the network makes a request, the browser rather makes a request to the network, go and get the content from serpwizz.com, and your server will say, okay, here you go, and it flings it back to the network, and that flings it back to the browser, and hey presto, it loads. So as it says here, there might be a lot of work that needs to be done on the server side, and it depends upon where the query is coming from. So you get page caches, which means temporary content that's stored in your browser to speed up basically response times for actual websites you regularly return to. So it might not be pinging back the server again on that second time around. It's just going to load content from your cache. So the way to get around that, there's been an update on the website and you're yet to register it locally, is that you clear your cache and then it pings the server because it says, well, we don't have any more content here at the moment, so we need to go back to the server. It also depends upon what kind of request it's making. So if it needs to request, for example, it says here order history, then it's going to request it from your database, and that's dynamically updated information, which means it's going to continually request it from the server, potentially depending upon how sites work. And this is where my development knowledge falls down a bit. It could be just specifically that piece of information that it loads, but my assumption is it's the whole page broadly. Ultimately, you want this to be as quick as possible, ultimately, to make sure that the initial server response time is as fast as possible, because everything else rests upon that, okay? So as we go down, there's some things here that I don't know enough about. So the server's application logic, I would say talk to a developer. Optimize how your server queries the database or migrate to faster database systems. So depending upon the structure of your database, if it's MySQL or PHP, whatever it is, then having either a faster database or optimizing how the queries are handled would make sense. And then your server, you could just be, your server is a physical storage somewhere that contains your information, which is where it's been requested from locally somewhere around the globe. But from your perspective, it's globally. And you could say, look, give us a bit more memory allocation or CPU allocation for processing power, as well as actual, stuff that you can store. So you could ask your server or your host for that, and they would come back to you with some insights and information. So there's some stack-specific guidance, as it says here. Optimized themes are one of them that come across. Optimized themes are big for WordPress as well as for Drupal. And then also looking at caching is also interesting and useful. Same thing for optimization plugins in WordPress, depending upon how much information you want to store locally, and then how much information wants to be held by or on the server side. So they're the two things. And then there's more detailed information. Well, for Magento, there's an integration it speaks of. I don't know enough about it to know. And then React has its own insights as well about consider using Node Stream effectively. So There's probably going to be more information outside of this, but I hope it gives you a really good handle on how to think about reducing initial server response times. Catch you in the next training. And well, you know what? I just want to say, let's quickly load this because it's hopefully it's implicit for SEO, but we will take a look at it. And 7 ways to reduce server response time, which we've spoken about. So it's got some of the best open source databases, minifying scripts, monitoring PHP usage configuration, keep WordPress light, optimize databases, use a CDN, reliable and fast hosting. And if we then look for the word SEO, and we'll put that in brackets, speech marks has to appear. You'll see that slow performance affects a page's SEO. So that's probably very obvious to you, but I hope that makes sense, guys, and catch you in the next one.